In this video, we are continuing to talk about reactions of aldehydes and ketones. In the previous video, we talked about nucleophiles like water and alcohol. In this video, we will talk about nucleophiles where nitrogen is the attacking atom. So we will look at nucleophiles like primary amines and secondary amines. Okay, nucleophiles like primary amine and secondary amines. Okay, so let's start with a primary amine. So if you have a aldehyde or a ketone and you react it with a primary amine, again in an acidic medium, so I'll just put it like here. Let's put an example of primary amine like simple 1CH3NH2. What you will end up in forming is a product which looks like this. N double bond N NH2. This is what is called as an imine. Okay, so we still have a pair of lone pairs of nitrogen atom, and this is called as an imine. Imines are compounds which contain a carbon nitrogen double bond. Okay, and they are also called what are called as Schiff bases. Okay, CHIFF, Schiff base. And the formation of this imine is again follows a few steps. So we'll line them up around, there are about 6 steps here. So the mechanism of the reaction is as follows. This reaction has to take place in an acidic medium. Okay, the most ideal pH is around 4.5. Okay, so we'll talk about that in a little bit. Let's look at the mechanism. The first few steps are very similar to what we saw in the formation of acetal, that is reaction with the alcohol. Okay, so if you have a ketone here, and since it is an acidic medium, I'm going to write the acid as HA. Okay, first step would be protonation of the oxygen atom. Remember, in an acidic medium, the first step is always protonation. So double bond O, oxygen gets a positive charge, one lone pair. Okay. The next step would be the nucleophilic attack. And here, what is a nucleophile? We have the primary amine, right? So let's draw this as CH3 NH2. Okay, this is my primary amine, and it's going to attack at this carbon atom, okay, at the electrophilic carbon atom, putting these electrons back here. So what do we get? We have a single bond to O, H, correct? And then the nucleophile gets attached in this manner. So we have N, H, H, CH3. Right? You could also put that as R in general, but I just have the specific amine, methylamine. Now, what did you see here? Nitrogen has 4 bonds, so it gets a positive charge, right? Okay, so what would be the next step? Now, this is what is would be similar to what we saw in the acetal formation, a tetrahedral intermediate. Okay, the next step is where the A, which was kicked out here in the first step, right? This one. A minus, that's a base, is going to grab one of the protons. It could grab each one, any one of them, put the electrons back here. So now we have a neutral species with an OH. We have a N, CH3, H, this here, right? No charge on nitrogen. Nitrogen gets back its positive pair of electrons, and this structure here is what is called as a carbinol amine. Carbinol amine. All right. Okay. So it doesn't end here. It goes again steps. Now remember, these are all reversible steps. Okay. So I need to keep on putting the equilibrium, showing the equilibrium. Okay. So we have here this reaction with the HA again. What will happen is one more time, there is a protonation of the oxygen atom. Let me show it here like this. It takes the hydrogen. So what do we get is a nitrogen with a CH3, H, and then we have O H and H with an oxygen with a positive charge, right? Now what's going to happen is very similar to what we saw before in our acetal formation. Water molecule leaves, so we can put minus H2O, and but carbon has to maintain its neutrality, right? So what will happen is this nitrogen with its lone pair is going to form a double bond. So that's how we end up in formation of a double bond to nitrogen with a CH3 and a H. Now nitrogen has a positive charge here because it has got 4 bonds, right? So water molecule is given off and we get this compound with double bond to nitrogen. Now here in the last step is where the A minus, which is the base that is kicked out here, that goes and takes the proton, puts this electron back, and you get this imine, which is your final compound. Okay, so this is how the imine is formed from the ketone or the aldehyde. Okay, now remember that this different derivatives of this amine could be used, and depending upon what starting the compound is used, you will end up in different kinds of products. Okay, but you need to know the mechanism of this reaction. As I was saying, the pH of this reaction is very important, because if the pH is too high, then the carbonyl group is not protonated. Okay, that means if you do not use a acidic medium, right? If it is very basic medium, then the carbon cannot be protonated. The carbonyl group cannot be protonated, and also if the pH is too low, then also then what will happen is the amine molecule will be protonated, right? So that is also a problem. Therefore we need to maintain the pH to around 4.5 for this reaction to occur well, right? Okay, now for your practice, what you can do is take another amine and another ketone molecule. Say for example I use this, and then ask you to complete the product of this. C2H5NH2 is my amine, and in presence of acid. So I want you to write down the product as well as the mechanism of this reaction. Okay, you can try this out and see if you can get this mechanism of this reaction correct. Okay, so first of all you need to write down the product, and based on the previous slide you can write down the mechanism of this reaction again. Okay, all right. Now remember, this is taking place in the presence of a acid. All right, so as I was saying, depending upon what kind of derivatives of you use, of amine you use, you can get different products. For example, if you take again a ketone here, and then say for example you react it with hydrazine. Okay, hydrazine is H2N NH2, and again in the presence of acid. So remember, whenever we need to put the acid, we can put it like this. Okay, so what can you end up with is R. Remember, it will be again a double bond to nitrogen, that's for sure, and then here you will have an NH2. Okay, so from the so this is what is called as hydrazine. This is hydrazine, and a reaction with this will result in what is called as a hydrazone. Okay, so depending upon what kind of derivative you are using of ammonia, that you can get different types of products. Okay, another example to illustrate that would be if you use this, and the compound is this one, OH-NH2, same thing with acid. What will you get here? R double bond N, and then OH here. Okay, so maybe we can highlight the group that gets attached to the NH2, this one here. So this is the NH2. Okay, if you have this one as OH NH2, then the OH gets attached to the nitrogen atom. Okay, so make sure that you will be able to write down the products when the starting materials are given to you. Okay, so and following this same thing, so we need let's put a black pen here. Okay, so R double bond O R, and then if it was CH3 NH2, right, just as we did before, CH3 and then NH2, then your product will be R, then double bond N, R, okay, and then what will be attached here? The CH3 group. So maybe this color combination will help you to identify what groups will be attached to the nitrogen. Okay, so this is your imine. This is actually called as an oxime, and this is a hydrazone. Okay, so depending upon what kind of starting materials you're using, again, don't forget to put the acid, otherwise this reaction will not take place. So in presence of acid, you get these kind of products. Okay, all right, now we need to look the secondary amine, right? Remember we talked about that nitrogen nucleophiles are where we use primary amine or secondary amine. Okay, so for secondary amine, the reaction happens very similar to that of the like that we saw in the primary amine, but here the product is actually called as an enamine. Okay, so let's look at the secondary amine reaction. So reaction of aldehydes and ketones with secondary amine, secondary amines. So let's dive down the overall reaction. So for example, if I have an ketone and in presence of a secondary amine, so for example, let's put it as CH3 twice NH, right? This will be a secondary amine. What will you get? Double bond N, okay, and then we put a CH3 here and a CH3 here. Okay, so let me erase it and redraw this here a little more cleanly. Okay, so what we end up is double bond N, you get a CH3 and a CH3. Oh sorry, you won't get a double bond here. Actually, you get a double bond here. Okay, so this is what is called as a enamine. Okay, the other one was imine. This is called as an enamine. Okay, now let's look at the mechanism of this, which will be very similar to that we saw in the imine formation. However, here instead of having a carbon-nitrogen double bond, we have a carbon-carbon double bond. Okay, so let's see how that happens. So let's take the same ketone. Remember, it's an acidic reaction, right? By now you all know that what will happen if the reaction is happening in an acidic medium. First step will be protonation, right? You have a double bond O, H, positive charge, okay? And then in the next step, nucleophile will attack. And here, what is a nucleophile? We have the secondary amine, right? So let's use the same one, CH3 twice, NH. Now remember, it is the nitrogen atom that is going to attack. So let's show the arrow here in this manner. Electron goes back over here, and then we have an oxygen getting back its pair of electrons. But now we have this nitrogen here with H, CH3 and a CH3, right? Now this will get a positive charge because nitrogen has 4 bonds. Got it? Okay, now the next step would be where the base, which is my A minus, right, which was given off in the first step, is going to take what? This proton, right? Putting these electrons back. It's a very similar mechanism to what we saw before. So we are repeating ourselves in several of these steps. So we have a CH3, two CH3s to nitrogen, and nitrogen loses its charge now because it's got its pair of electrons, and this is a what we saw before, right? So far the steps looks exactly like the primary amine reaction. But here is in the next step, what is going to happen is protonation again, right? So with the oxygen getting protonated, and here we can continue. We will get a OH and an H. Oxygen gets positive charge, and we have this nitrogen with a CH3 and a CH3. All right. Now water molecule will leave, but at the same time we have to maintain the octet of carbon, so this forms a double bond, and we end up with a double bond to nitrogen, CH3, CH3, and the water molecule is given off, minus H2O. Okay, and here again I should remember to put all these as equilibrium arrows because it is a reversible reaction, so should show like this, all of them. Okay, all right. Now here nitrogen gets, to get rid of this nitrogen's positive charge, in the case of imine we had a hydrogen which could be grabbed by the base, right? But in this case there is no hydrogen, so what's going to happen is, remember this carbon has hydrogens here, right? These are CH3s. So this base A minus is going to take a proton from here and then put these electrons over here and give these electrons back to the nitrogen atom. Okay, so that's how we end up in the double bond for double bond between the two carbon atoms, and nitrogen now becomes the doesn't have a charge anymore. This structure is what is called as our enamine. So you can clearly see how we did the mechanism of imine and enamine. Okay, you need to know both of them. With secondary amine, the reaction forms enamine, and with primary amines, aldehydes and ketones form what are called as imines. Okay, all right, and like here again the pH is important. pH is around 4.5, which is what we have to maintain in order to get a good yield of our product. Okay, all right, so now one more reaction we can do in this is what is called as a Wolff-Kishner reaction. This one I am not going to expect a mechanism. We will just do the final product here. So we just a little while ago we talked about formation of hydrazone, right? So we said that if you have an aldehyde or a ketone, and if you react it with hydrazine, NH2 in the presence of acid, what you can end up is a double bond N with an NH2, right? This is called as a hydrazone. This is a hydrazine, right? This reaction, if you take it up further and react it with a base KOH, okay, what you can end up with is just an alkane. Okay, so you can actually change an ketone or an aldehyde to an alkane by doing this Wolff-Kishner reduction. Okay, so you can first turn that into a hydrazone like this. So use hydrazine to convert into a hydrazone, and then react it further with base under strongly basic conditions to give this alkane. Okay, so another example would be, I'm again not looking at the mechanism of this. So if you have something like this and you want to convert it into this, right? If I ask you what the reagents would be, you can say that first you can convert this ketone to a hydrazone. Okay, so you put NH2, and for that what will you need? You will need hydrazine, right? NH2, and then in the acidic medium. So this is what you will need first, and then you react it under strongly basic conditions like potassium hydroxide, and you end up in the formation of a alkane. Okay, the side product is actually nitrogen, but if you just show me the main product, that is good enough. Okay, so this is called as a Wolff-Kishner reduction. It's a reduction reaction, okay, because you're reducing it to an alkane. and I'm not looking for the mechanism, but I really want you to know how to convert an aldehyde or a ketone to an alkene. Okay, so stop this video here, and in the next video we'll talk about carbon nucleophiles.